define mode, there are additional simulation and meshing options available. Let's first discuss the simulation options. In the simulation tab, under the physics section, you can find the simulation options. Clicking on it will open a drop-down menu. Here you can change the convergence settings and you can change the convergence criteria from engineering convergence to numerical convergence or molded value convergence. For this case, we will stick to engineering convergence. You can also change your solver. By default, LiveGX GPU is selected, but you can change it to CPU if you want to use both your CPU and GPU to run the simulation in parallel. It is important to note that GPU memory consumption is 1 GB per 1 million mesh elements in the best case scenario. If your GPU is not powerful enough for the physics and mesh you have, then use either LiveGX CPU or Fluent CPU to solve. However, the LiveGX solver is unique to CFD for the time being and cannot be applied to any other physics like structural. If you uncheck the LiveGX solver, then you will be choosing Fluent CPU solver. To use the Fluent CPU solver, you will need a CFD premium license or higher. Additionally, you can also specify the turbulence modeling method from this menu. The default is K-Omega SST, but you can choose any other model by clicking on Specify Modeling Method and then selecting the desired one. You can specify your convergence settings too. Here you can set the maximum number of iterations and target convergence criteria. Then we have meshing method. From here you can specify your meshing method. By default it is tetrahedra, but you can change it to polyhedra. Let's change it to polyhedra mesh. Then we have the auto adjust quality option that is turned on by default. As the name suggests, Discovery automatically adjusts the mesh quality in low fidelity areas. Lastly, we have simulation unit settings. You can change your simulation unit options from here. I am using the metric system here, but you can change it to imperial if you wish. For simulation and meshing, we will use the GPU based LiveGX solver and polyhedra respectively. The meshing tools are located under the simulation tab in the fidelity section. Here we have a global option to modify the global sizing method. By default, it is set to determine size automatically, which usually works well for most cases. However, if we want to change it, we can click on the three dots and select a different option from the drop-down menu. For example, if our geometry contains some narrow channels, we can choose proximity. We can also adjust the predefined setting by clicking here and changing the relevant values as needed. The same applies for other options also. For this demo, we will stick to the default option of determine size automatically. Below the global settings, we have the option to apply local fidelity sizing to any body or surface. We can do this by selecting the option and then the geometry where we want to apply it. Then we just need to enter the element size from the right side of the HUD. We already have local fidelity applied to the system, which we did in the Explore mode, so we won't modify that. To solve this setup in the Refine mode, we can either hit the Solve button to start the simulation or generate the mesh by clicking on the Mesh button. After meshing is done, if we are satisfied with our mesh, we can hit on Solve. If we hit on Solve before generating the mesh, Then Discovery will generate the mesh first and then start solving the moment mesh generation is complete. You can see the mesh statistics when they are available by going to the notification section. The meshing task is completed when the green revolving line reaches the half mark on the simulation information display or SID. To see the generated mesh, click on the same mesh icon next to the solve button once your meshing is done. Let it run for now and then we will talk about some results here in refine mode and how much difference we are seeing from the explore mode. The solution is complete. Let's open all the mass flow rate monitors that we created previously in this course. Click on the monitor icon and select each of these monitors to view them. Here you can see the results from all the design variations that we ran in explore mode using a parametric sweep analysis. You can click on the chart icon to show or hide the results of different variations. The circular dot indicates the value from the explore mode and the triangle represents the value from the refine mode. For the mass flow lower front and mass flow lower back, the difference is negligible, but for the mass flow upper front and mass flow upper back, there is some discrepancy between the explore and refine results. However, the difference is within 10% for all the monitors. We recommend using the explore mode to quickly iterate on design ideas with simulation as a guide. However, once you have the optimal model and boundary conditions, you should verify the results with the refine mode by using our high fidelity solvers like Fluent and LiveGX. In Discovery, you can also transfer your whole simulation setup, including your geometry, physics boundary conditions, materials, mesh, and solver settings directly from Discovery to Fluent. To transfer with a single click, you can click on Transfer to Fluent from the Simulation tab on the top ribbon. There is also one more option to transfer, and that transfer option is only for your geometry. That option is available under the Prepare tab in the Geometry Transfer section. From here, you can transfer your geometry to Workbench, Mechanical or Fluent.